So, hello, this is a video about feedback control systems, an introduction. So, this is a motivational example and is dealing with multi-agent systems. And I call this example rabbits in the open loop. So, the problem can be stated as this. Okay, let's consider an hypothetical problem with a farmer who is conducting an experiment and releases a group of rabbits into a meadow enclosed by a fence. Then he doesn't have any further interference in the process. So he's only able to watch or observe what is going on. And this rabbit is thinking, what might happen in these circumstances? So it depends of a lot of things. So I consider it like several cases. Case one, I call it a beautiful dream that turned into a nightmare. So in this case, there is no lack of grass, no diseases, and no natural enemies. So what is going to happen is like the rabbits are going to breed like rabbits, and is going to there's going to be a population explosion, and we get this rabbit here thinking, oh, this is too crowded. Okay, so in this case, you can think there is an intrinsic feedback in this system, so it is in an open loop, but okay. The feedback is okay. There is no problems, no problems with the grass. The grass has energy, and no enemies, so the feedback is positive. Okay, so that's why they keep breeding with no restrictions. So case two is the rabbit's paradise. Okay, there is no lack of good grass, but there are some natural enemies and some weeds. And okay, so in this case, there is a negative feedback as well, and this is going to balance. There is going to be an equilibrium, so a population equilibrium, and you can see the rabbits here really happy in paradise, and the rabbits nightmare. So they have natural enemies, for instance, foxes, diseases. The climate was not doesn't help, and the grass has little energy. So there is a decline in the population, and they can even die. Or so it can be an extinction. And you get here a news from the Guardian saying, okay, run rabbits, why they are disappearing from the countryside, and we can blame the crops and also the predators and diseases. Okay, so the objective here is to use a kind of model from NetLogo, and it's called the rabbits grass weeds model, and it was developed by by Wilinski. It is in the library from the NetLogo, and we got here some sliders. You can change the number of rabbits, and then you can also have uh, a setting for the birth threshold. This is the energy necessary to breathe. And then you got the grass grow rate and the grass energy, and the weeds grow rate and the weeds energy. So we can also we got here a plot to see what's going on. So the objective in case one, so if you with these settings that you can see here, we are going to what is happened is like the beautiful dream that has turned into a nightmare is that okay, so many rabbits, there's an explosion of rabbits. Okay, and in case two, there is like no, sorry, this is like yes, case two. There's like okay, also the increase of the number of rabbits, but in this case, it settles in a steady state value, which is smaller. Okay, and the case three. Uh, okay, in this case, with these settings, there is the population extinction. Okay. Okay, so this multi-agent system can be considered an open loop system. So you can have here, for instance, considering that waiter as the grass energy, and then the artificial ecosystem with the rabbits, and you can have here disturbances like this one, load one affecting the grass energy, and output one affecting the number of rabbits. And okay, so you can consider like a disturbance, for instance, imagine here where you can have the a steady state value or oscillating around this value, and then we got a disturbance, and the number of rabbits decreases uh, drastically. So it doesn't compensate the number of rabbits because this is an open loop problem. Okay, but imagine now that the farmer, which is represented, is going to interfere. So he's going to measure and use the measure of the number of the rabbits, and then he can act like for with fertilizers for the grass, feeding the rabbits with extra food, doing pest control, medicines, and so on. So this is one thing that we are not going to see here. It's going to be seen in the next video. And in this one, I'm going to try to show you um, one demo, okay, where I'm going to put here the number of rabbits. I'm going to put okay 20 as I show you. Then I'm going to put here 20 in this value for the grass grow rate, and then 10 for the grass energy, and the weeds growth rate is 0 and the weeds energy is 0 as well. So I do the setup. I have the 20 rabbits in the field, some grass, and then if I do press the go, you can see here, as you can see, that there is an explosion, a lot of rabbits, and then the number of is going to be quite high, and then we got this oscillatory behavior, and is a kind of predator-prey oscillation. Okay, with this one is the first one, what seem heaven, but is really a nightmare. And then the second one, I'm going to put like here now, 8 for this one, well, this setting, and it with energy 2.5. Okay, and if I do this and I press setup and I press go, okay, in this case, sorry, I should have put no, okay, not this one should be 15, and this one should be 5, and okay, with 8 and 2.5 set up and go. Okay, you can see that the number of rabbits is going to reach a smaller number. So in this case, it could be the equilibrium is reaching like around 300 or something like that. Okay, and the next case is a drastic case where I'm going to put here where the grass grow energy is going to be very small, 4, and also the grass energy is going to be 2, and in this case the weeds grow rate is going to be 0, and the weeds energy also 0. Okay, in this case, setup, if I go, okay, what happens is like, okay, all the rabbits die. Okay, so this is the extreme case. So I'm going just to show you again, putting again here 15 and here 5 in the grass energy with some widths here 8, and in this point here 2.5 for instance. Okay, if I do this now and I do the setup and go, okay, you are going to see, okay, now we got the widths as you see in the purple. So there's an equilibrium here, okay? So this is an open loop, so this a self-regulatory system, a complex system that there is balancing around this value. But now I'm going to apply a disturbance. In this case, it's going to be in the grass energy. I'm going to reduce this value here, for instance, for 1. Okay, I'm going to put for 1. You see, and you can see a drastic drop here in the population of rabbits because this is an open loop, so there's no control about the number of rabbits. So also I can increase the number of the birth threshold, and the system becomes slower. Okay, so with this demo, I conclude this presentation, hoping that you enjoy it. And then the next one is going to be about closed loop. How can we control the number of rabbits with closed loop? and I think you're going to enjoy it best. Thank you for watching. Bye.